All right, you guys, let's take a look at section 6.6, the last one in chapter 6 here. So we use properties of special parallelograms. So our parallelograms were rectangles and rhombuses, or rhombi, sorry, and squares, and all of the properties that went with those. Now we're going to take a look at some things that are quadrilaterals but are not parallelograms. We're going to look at trapezoids and kites and all the properties that go along with them. So some terminology here. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay? On a trapezoid, those parallel sides are called the bases. And I'll give you a picture of this in a little bit. The legs of a trapezoid are the non-parallel sides. The base angle is the angle formed by one of the bases or the parallel sides and one of the legs. An isosceles trapezoid is a trapezoid that has legs that are congruent. The mid-segment of a trapezoid is a segment that joins the midpoints of the legs. And a kite is a quadrilateral with exactly two pairs of consecutive congruent sides. So those are the kinds of things that you should have in your notes, and then some properties that go with them. If I were you guys, I would have a spot in my notes for each different shape, parallelogram, rectangle, rhombus, square, trapezoid, kite, and then list all of the things that are true about them. If you have it organized that way, it's going to make doing the homework and eventually the test much easier. Okay, so here's what I mean by a trapezoid. So the top and bottom are parallel here, so those are considered the bases. The legs are the sides that are not parallel. These appear to be congruent, the legs, so I would say this is an isosceles trapezoid. A base angle is an angle that's formed with the base and a leg. So some of that terminology we'll use throughout the rest of the PowerPoint here. Okay, some things that are true about an isosceles trapezoid. So I know that the legs are already congruent, but if a trapezoid is isosceles, the base angles are congruent. So F and J are congruent, G and H are congruent. If a trapezoid has one pair of congruent base angles, then it's isosceles. So if I told you this was a trapezoid, and I showed you that those base angles were congruent, it would have to be a trapezoid. Okay? And if it's an isosceles trapezoid, the diagonals are congruent. Which is why, think back to rectangle. In order to prove that something was a rectangle, we first showed it was a parallelogram with congruent diagonals. Showing the diagonals are congruent wasn't good enough because it might have been an isosceles trapezoid. Okay? So a quick proof as to why the diagonals are congruent in an isosceles trapezoid. So if you look at this isosceles trapezoid over here, DC and CD are congruent, so I know that I've got that base. It's really a shared side of a couple of different triangles. AD and BC, because the legs of an isosceles trapezoid are congruent. And then angle ADC and BCD are congruent. So you've got a couple of triangles that overlap, ADC and BCD. And by side angle side, those two triangles are congruent. And if the triangles are congruent, then their corresponding parts are, and AC and BD are corresponding parts, and so the diagonals have to be congruent. Okay? So let's take a look at this. So if the basket there has the shape of an isosceles trapezoid, the measure of angle JML is 130 degrees. KN is 6.7. LN is 3.6. They want me to find the measure of angle MJK, this one here. All right. Let's think about what we have here. We have an isosceles trapezoid. By definition, a trapezoid has one set of parallel sides. Okay? So I know those are parallel. Well, think back to chapter 3. If two parallel lines are cut by a transversal, MJ would be our transversal, the consecutive angles are supplementary. So this 130 and the angle I'm looking for have to add up to 180. Well, now I think I've got a pretty good way of finding that missing angle. Okay, so they're going to walk you through that idea. Consecutive interior angles have to be supplementary. I knew that one of them was 130, subtract, the other one's got to be 50. Okay, So now, what if I use some of that other information? I want to find Mn. Okay, so they tell me that Kn is 6.7, and they tell me that JL, that entire diagonal, is 10.3. Well, in an isosceles trapezoid, the diagonals are congruent. So if this one's 10.3, so is that one. So 6.7 plus, we'll call it x, has got to be that 10.3. Pretty straightforward little equation to solve. Okay, and so that's all they're saying. The diagonals have to be congruent. One diagonal will be the sum of those two smaller parts. I've been given a couple of the numbers, subtract. The other one's got to be 3.6. Okay, so pause the video. Give this one a shot yourself. All right, so we're looking for EFG. They want me to find that angle right there. They've given me FGH. Well, from a previous slide, we learned that the consecutive interior angles have to be supplementary. So if I take 180 minus 124, I should have my result, 56. Okay. Similarly, I don't know if I have all the information showing here. It's funny, sometimes it doesn't go through, but it's the same thing. You would have had a scenario where the diagonals have to be congruent, and the sum of these two would equal a third one if they had given me all that information. Okay, so coordinate proof. I'm given that this is a quadrilateral, and I want to see if it's isosceles, if it's an isosceles trapezoid or not. Okay, can't assume it's a trapezoid, and I can't assume it's isosceles. The best way to prove that it's a trapezoid is by definition. Exactly one pair of parallel sides, and the only way to prove that things are parallel or not is to use slope. So I'm going to find the slope of all of the sides. If the slopes are the same, they're parallel. If they're not the same, they're not parallel. And so if I have one set of sides parallel, we're good to go. Now, to prove that it's isosceles, I'm going to use the distance formula and try to show that the diagonals are congruent. If they're congruent, it's isosceles. If not, it's just a trapezoid. Okay? So let's see what we're going to do here. So I take those sides, and I apply the slope formula, y2 minus y1 over x2 minus x1, for each of the sides. Okay? And if you want to go back and try this with those numbers, you certainly can. Here's the numbers you get. Well, now, these two sides have the same slope, so they're parallel. These other two sides do not have the same slope, so they're not parallel. Well, if I have a quadrilateral with exactly one pair of parallel sides, this is a trapezoid. So I know for a fact it's a trapezoid. Okay? Now, how do I know if it's isosceles or not? We're going to measure the distance of the diagonals. If the diagonals are the same length, then it's isosceles. So AD is one diagonal. We get the square root of 18. You don't need to simplify it. We're just trying to determine if they're the same or not. BC is your other diagonal. Using the distance formula, get the square root of 17. They're very close, you guys, but they're not the same. This is not an isosceles trapezoid. I can call it a trapezoid, but it's not isosceles. Okay? All right, so pause the video, give this a shot yourself, and then we'll look at it together. All right, so we're supposed to determine if the four vertices here create a trapezoid, and if so, is it isosceles? So the first thing we're going to do is we're going to find the slopes of the sides. Okay, so QR, 2 minus 0 is 2, and 2 minus negative 1 is 3. So that's the slope of that side. RS, okay, 0 minus 2, and 5 minus 2, negative 2/3, okay? ST, negative 4 minus 0, negative 1 minus 5, I get 2/3, okay? And then, of course, QT, negative 4 minus 0, and negative 1 minus negative 1, okay? That means an undefined slope or a vertical line, okay? I'll just put vert for vertical. Well, these two here have the same slope, which means they're parallel. And the other two do not. One's a vertical line, one's negative 2/3 for a slope, so they're not parallel. This is a trapezoid, for sure. Now I need to go ahead and measure the lengths of the diagonals. Okay, so QRST, if you were to think of QRST, QS is a diagonal. Okay, so the change in the x's from 5 to -1 is 6, and from 0 to 0 is 0. So I get 6 for that diagonal. The other diagonal is RT. If you're a visual person, go ahead and put this on graph paper to see what you've got, okay? So RT from -1 to 2 is 3. And from -4 to 2 is 6. So 36 plus 9. It's 6 point something, but it's not the same. So this is a trapezoid because one pair of parallel sides, one not. But it's not isosceles because the diagonals are not congruent. All right. A mid-segment of a trapezoid, if you remember, joins the midpoints of the legs. This theorem says that that mid-segment is parallel to the bases, and the length of it is half the sum of the bases. So if I add up these two bases and divide by 2, I get the length of the mid-segment. That's something you should have in your notes for sure. So, in the figure, MN is the mid-segment of the trapezoid. What is the value of x? Well, x plus 20 divided by 2 has to equal 30. We're just going to use that formula and then solve for x. Okay? So this is what we learned from the theorem. 2 of those 3 values I've been given. I've been given this one was 30 and the mid-segment was 20. So multiply both sides by 2 over 1 to get 60. Subtract 20. That missing value is 40. Okay? So, similar situation. JK is 18. And WZ is 25. And they want me to find XY, given that KJ is the mid-segment. So pause it and give this a shot on your own. Okay, so what we learned is that the mid-segment is equal to half the sum of the bases. So that's the formula that we would use. Now I just have some algebra to do, you guys. So I'm going to multiply both sides by 2 to get rid of that 1/2. 18 doubled is 36. I have to subtract 25. I should get 11. Okay? Nice job. All right, so a kite, switching gears a little bit. We learned that a kite is a quadrilateral with exactly one pair of, well, we have 2 pairs of consecutive congruent sides, but not all the sides are congruent. So these 2 sides are congruent, these 2 sides are congruent, but all 4 aren't. Because if all 4 of the sides were congruent, it would be a rhombus. Okay, so a couple of things about a kite. If it's a kite, the diagonals are perpendicular. Well, that's true about a rhombus as well, but in order to prove that it's a rhombus, you'd have to first show it's a parallelogram. Okay, here exactly one pair of opposite angles is congruent. Because if both pair of opposite angles were congruent, it would be a parallelogram, and we would have a different shape. So a couple of theorems that we're going to use on the next couple slides here. So I know it's a kite. Find the measure of x, y, z. All right, couple of things. I know that one pair of opposite angles is congruent, and it's the one in between the non-congruent sides. So that has to be 121. I also know from the beginning of the chapter that the sum of the interior angles of any figure is n minus 2 times 180. So there's 4 sides. 4 minus 2 is 2. Times 180 is 360. So I know all 4 of those angles have to add up to 360. Well, I'll take the 3 that I know, add them up, subtract from 360, and I've got my missing angle. Okay? So that's what they're saying there. They have to add up to 360. I've been given 3. Add them up, subtract. 45 is your missing angle. Okay? The other thing that I'm going to utilize here is the fact that the diagonals are perpendicular. And if the diagonals are perpendicular, then I can use the Pythagorean theorem in a right triangle. So 6 squared plus 8 squared should equal mn squared. Mn is going to be 10 for us here, solving that formula, and these two sides are congruent, so then Np is also going to be 10. So you're going to see them work through that here in a little bit. This is just the Pythagorean theorem. I knew the sides to be 6 and 8 of the legs of that triangle. Solve and I get 10, and of course the other side was congruent, so NP was 10 as well. All right, give yourself a second, pause the video, try this problem. Okay, let's go through what we did before. One set of opposite angles has to be congruent. All of them have to add up to 360. So 64 plus 130 plus 130 plus the measure of angle D has to be 360. Okay? So what do you get? 260 plus 64 is 324. I have to subtract 324 from both sides, and I'm left with 36. That should be a 36-degree angle. If you got 36, give yourself a pat on the back. Okay? All right. Pause the video again. Try this one. I'm looking for KL. Okay, so remember that in a kite, the diagonals are perpendicular. So I'm able to say that 3 squared plus 4 squared equals kj squared using the Pythagorean theorem. So a little bit of algebra gives me that. Take the square root of both sides. Okay? So I know kj has to be 5, and kj and kl are marked congruent, so a is going to have to be 5 as well. If you got 5, give yourself a pat on the back. All right, and that's it, you guys. Trapezoids and kites. So there's your assignment. Notice we're skipping a lot of the proofs. Give everything else a shot, though, so that you're ready for the test. Good luck.